Hey everyone, this is 13-7, volume and similarity. Similar objects in 3 dimensions. We talked about similar objects in 2 dimensions. We talked about the impact on the area growth of similar objects late in chapter 12 or unit 12. I quizzed you and tested you on that kind of thing. And we talked quite a bit about this in my last Zoom class discussion. So there's nothing new to talk about in this lesson, but let's talk about it one more time and let's go through another example problem. And of course, you're going to have these notes available to you when you get to the homework. So here's the one problem we're going to do today. It's going to be a short video. Campbell's is producing 2 different sized cans of tomato soup. All right. And so here are the costs associated with the production of the store-sized small can of soup. And here's all these costs laid out for these different parts of the product. Now, let's take a careful look at this note here. It says, note that the label is glued. Save the Google Drive. No, I don't want to save this at all. The label is glued by wrapping the label around the can and then laying a thin strip of glue along one edge of the label and then pressing the edges of that label together. So if this were the label that was going to be glued around a can, right, we're going to wrap that around the can and then just a thin strip of glue along the edge here to glue those 2 edges together around the can. Okay, it's important to understand how the glue is being used there. All right, so now they're also going to produce an industrial size can of soup for use in a soup kitchen somewhere or something like that. And this new can is going to be 5 times that of the small can. So 5 times the radius, 5 times the height. All the dimensions are 5 times as much. Okay, now you've learned enough by now to know that not all of these costs are going to be multiplied by 5, because not all of these costs are associated with linear types of measures or linear types of things. Okay, so what are the new costs? Well, let's talk about the soup. What is the soup? Is it a length of stuff? Can you eat 6 inches of soup? Can you eat 6 square inches of soup? Is soup an area or a soup of volume? Can you eat 6 cubic inches of soup? Yeah, clearly soup is a volume of stuff, right? So the cost for the soup in the larger can is not just going to be multiplied by 5. Okay, soup is a volume of stuff. And so its cost, 25 cents, is not going to be multiplied times 5, but rather times 5 cubed. Okay, volume is a cubic measure. And when you have similar things growing, the volume grows by the cube of the factor that the lengths are all growing by. 5 cubed is 125, and then times 25 cents. I believe that is 3,125 cents. And you could give your answer like that. That would be totally fine. But we don't really ever communicate in terms of thousands of cents. We usually turn that into dollars, right? So that would be $31.25. But this is a perfectly acceptable answer as far as I'm concerned. Okay. How about for the metal can now? Okay. What is the metal can? Okay. What kind of stuff is that? Is the can the metal being used to make the can? Is that a volume of metal? Is that an area of metal? Is that a length of metal? I'm not sure how obvious this is. It may not be as obvious as the soup, but the can really should be thought of as an area. Okay, the metal being used to make the can does not, the metal doesn't fill the interior of the can. The interior of the can is filled by the volume of soup, but the metal is just really around, it's just the surface area of the can, right? I mean, if you're really, really sharp, you might be thinking to yourself, yeah, but Mr. Nortillo, the metal isn't really completely theoretically totally flat. I mean, there is a thickness to the metal, even though it's super, super thin. There still is a thickness. I mean, there's a thickness to a sheet of paper, right? It's super thin, but there is a thickness to it, right? So in a sense, you are having to use a volume of metal to make the can. But here's the thing. When you make a larger can, the metal doesn't get any thicker, right? You're not going to use thicker metal to make a larger can. The metal is going to be the same thickness. It's just that there's going to be more area of metal. The thickness isn't changing at all. So it's really not a volume type of thing, the metal being used to make the can. It's an area type of thing. And so the cost of the metal for the larger can, because this is an area type of cost, is going to be multiplied not by 5 times, but by 5 squared. And 25 times 13 is 325 cents, which again is a perfectly good answer. 3,125 cents for the soup, 325 cents for the can. You could, of course, write that as $3.25, which is more commonly how we would communicate that. Okay. But 325 cents is good. How about for the paper label? Well, that probably isn't going to stump anybody. The paper label, that's paper. And just like the metal in the can, the paper is not going to get any thicker just because the can gets bigger. We're going to use a larger area of paper. And so the cost for the paper is going to be multiplied, again, not times 5, but because the paper covers an area, it's going to be multiplied by 5 squared also. So that's 25 times 2 is 50 cents. 50 cents. Okay. Now the glue, and again, I'll refer you back to my description earlier of how the glue was being used. We were just running a strip of glue, just kind of a length of glue to glue the edges of the paper together to each other. So this glue is being really used as a length. Now, theoretically, we could spread glue over the entire area of the label and therefore then glue the label directly to the can. But you've probably seen labels come off cans or jars, and you know that's not how labels are glued to cans and jars. They don't glue the label directly to the can or the jar. They wrap the label around and just glue the label to itself. But it's just by running a really thin strip of glue, and they glue the paper to the paper. They don't spread it over the whole paper. So this is a length of glue, and so the cost for the glue is going to be multiplied simply by 5 times. Okay, and so 5 cents for the glue. Before I end this video, let's talk a little bit more generally about what's going on here and the ideas of length and area and volume. Notice that money, okay, cents or dollars and cents, money in and of itself is not a length type of thing or an area type of thing or a volume type of thing, right? But money can be associated with the costs of lengths of things or areas of things or volumes of things, okay? And the same could be true for another very common measure, time, right? Time in and of itself is not a length type of thing or an area type of thing or a volume type of thing. But the time associated with certain events or actions or phenomenon may be related to the length of something, or might be related to the area of something, or might be related to the volume of something. I mean, let's say you have, let's say you're talking about the length of time it takes you to run around a track. Okay, that's a length associated time. But if you're talking about the time it takes to mow the grass in the middle of the track, to get a lawnmower out and cut the grass. Well, you're cutting that whole area of grass. So that sort of time is an area related measurement. And then if you're talking about the time it takes to, let's say, empty a box of salt, okay, where you're having to pour out all the volume of salt in that box to empty it, then that time is related to the volume of salt. Right? So very common measures like costs and time, which you're going to see show up again and again in the problems that I'm presenting to you in the homework and the quiz and the tests. You have to think about what those costs and times are related to. Are they related to length types things, area type things, or volume type things? And let me give you a tip that will be helpful in one of the homework problems. Okay. There's a homework problem that asks about the weight of two similar objects. Okay. You got a small, I think, model of an object, and then you've got a similar model of that object that's maybe 3 or 4 or 5 times as big. Okay. So if I tell you what the weight of the small object is, then you got to calculate the weight of the large. What is the weight dependent on? Right? That's a very common measure also, but is the weight dependent upon the length of something, or the area of something, or the volume of something? Mm-hmm. So think about that. The answers will be posted. Okay, give it your best shot and then check the answers. The answers will be posted. The answers will be posted to all of the problems that are like this one. There's 3 of them on the front page of the homework. The second page of the homework gives you one 3-dimensional object and challenges you to find the volume of that 3-dimensional object and the surface area of that 3-dimensional object. The answer to that problem is not going to be posted ahead of time. That one is going to be due again, turned in by you for homework, for a homework grade. So that's it. That closes this video lesson, right? Get after the homework, turn it in on time, and we'll see you next Zoom meeting.